My name's Mike Reynolds. We're here in Beaver, Utah. We've got some ore we brought up from our horseshoe mine. We're going to be running today at the mill here. We've got some different ore. We have some material that's called a dump material that was ore pushed to the side 100 years ago when they were milling at our mine site at the horseshoe mine. They didn't mill at the time because it wasn't high enough grade to get a good recovery. We also have what we call tailings, which is material that was milled and processed 100 years ago. We still have silver and gold in that, so we're rerunning some of that to see what the recovery can be there. So this material is the dump material. It was ore that was taken out of the mine shaft 100 years ago at the horseshoe mine. It was placed to the side. At the time, it wasn't high grade enough ore to mill. We're going to mill it, see if there's enough metals in it now the values are high enough to mill at this time. If you come a little closer, look at it a little closer, look underneath the microscope, you're going to see it's actual quartz material. The green rock is a higher grade ore. That's what we're after. That's gold there. And that's our goal, is to get the gold out of the rock. We're at the material that's called the dump material. It's a fine mesh sand. If you look at it, it's very, very fine sand. And this was processed about 100 years ago at the horseshoe mine, but there's still metal in it, and that's what we're after. We've transported the sand from our mine, which is a horseshoe mine, to this location, and we're going to run it today. We're in the process of running some of it right now, this material right here, which is the dump material. The crew that's working here today is very knowledgeable about the mill. They've taken a few years to put this equipment together. It's hard equipment to find, and Russell Lim's the owner, and he's done a great job putting this mill site together. Everything here has been MSHA approved, which is the mine safety regulation people. So you'll see a lot of the guards up in place inside the mill site. And like I said, there's no chemicals being used whatsoever. The process is a fairly simple process. We're taking the sand, we're putting it in a feeder hopper over here. The feeder hopper is going to relay it to a conveyor belt. And there's a machine that on the bottom of the feeder hopper that adjusts the amount of sand that's going onto the belt, so we know exactly how much material we're feeding per hour into the mill site, and it can be adjusted accordingly if we need to go faster or slower. The material, the sand, is going to go on the conveyor belt. It's going to go into a ball mill. It's going to lift up into a ball mill, and a ball mill is a big drum that has steel marbles inside it. They're about 3/4 inch around, and every time the drum goes around, the marbles fall down on top of the material and they crush it to a finer mesh. And that's the goal, is to crush it down to a fine mesh that liberates the metal from the rest of the material, the rest of the quartz material. But after the material goes through the ball mill, it's fed into the building into what we call dicer tables. There's 3 tables stacked on top of each other. They're approximately 8 feet by 20 feet, and they're about 17 feet high. The dicer tables are they're gravity separation. There's no chemicals used here whatsoever. And what they do is they shake back and forth, and because of the weight of the metal is heavier than the weight of the sand, quartz material, the waste material will go one direction, the heavy metals will go the other direction. At the top of the table, there'll be a fine line that'll start to form, and that'll be the heaviest metals. There'll be silver and gold in that fine line, and we'll get a good look at them inside there in the mill when we go in here in a few minutes. One of the neat things about this mill is that it's completely mobile. If you noticed outside, the ball mills were on skids. Everything's available, or everything's built to move out to a remote site and be able to operate out at the remote site. This whole dicer table assembly is made to take and move out to the mine site and run there. The power generator out here is not from the city or from the building here. It's from the generator out there, if you notice, through while we were walking in. So what's going on at this point is the material is coming through the ball mill, and it's being fed up to the top table. And it's got 3 tables here that are, like I say, shaking back and forth. The heavy material is going to one side of the table, the lighter material is going to the other side of the table, and at the end there's traps that are taken into different areas so we can capture the heavier metals. So what's happening is the material that we're trying to capture is coming off the table. It's going down into the tube, and it's coming into this 55-gallon drum right here. At the bottom of the drum, we've got about 6 inches of material now that we've captured. That's going to have to be refined again, but there's a lot of metals in that material, and that's what the goal is, to capture that metal. What we're looking at right now is the byproduct at the end of the mill. We're trying to make sure that we're not losing some of the metals. So we're looking at some of the tailings that have already been processed that are pushed back out into the holding pond behind the mill here. And we're looking at it through a microscope to make sure there's no metal in them. And it looks like there's not much in this sample, so hopefully we're getting it out of the table, off the table right now. And then at the 5-gallon buckets at the other end of the single table over there is some more grade A concentrates. That's like the finishing table, but the majority of them are captured right here in the 55-gallon drum. And these are, we could sell just these. These are the higher grade concentrates, and there is going to be a high content of silver and gold in these concentrates.